All right, we good to go. So, man, I didn't get back to you yet, but I will. Oh, yeah, I'll get back to you.
That all happened. Like just after a while, they were saying they couldn't try to work because they are say the host will move. Yeah,
For the homework
no.
or for tutoring?
Yeah,
Got you.
yeah.
You did that? I'm not even sure what that means. I've never seen that before.
Yeah.
So like, yeah, there's a secretary that is sitting there in the main room. I call it the main room, but like the main Zoom room.
Yeah.
And then like they're the ones in control of everything.
Oh,
Yeah. So like I didn't even know when you were coming in because I was in a whole nother room working with other people.
yeah.
And I can't even see what's going on in that main room.
Oh,
Yeah, like Zoom is funny.
yeah. At first, I didn't see you on and then after a while. I think I had to log out and I log back in.
Yeah.
And then I log in, I saw your name, but like, like you're in a different section.
Right. I was in another room, so I couldn't even see you. I didn't even know that you were there.
Oh,
Yeah. Like so Zoom is funny, like so like let's say somebody else comes in and then like I'm in the room working with them and then you log in, right? I can't see that you logged in. So the secretary can see that you logged in, and then they're the ones that'll like put you wherever and then they'll contact me. Literally have to call me because we can't even talk to each other, which is another thing. Like, yeah, Zoom is special. Blackboard never had that issue, but Zoom does. Oh, yeah. All right, so let's do one of these real quick. Didn't mean to do that. All right. Awesome. So, any questions from the homework you guys might have?
Yeah.
Oh, wait. Alex, go. No, yeah. 2/31? Oh, like this? Okay. 31? Oh, 3y. Got you. Sorry about that. All right. Say it again. SY? Like S, like Samson and yellow? Oh, XY. Got you. Like that. Got you. All right. No equal sign. That's it. All right. So in order to do this, right, you gotta simplify the numerator first, and then simplify, excuse me, the denominator after. And then when you have a fraction divided by a fraction, then you can do keep, change, flip, and simplify even further, right? So let's start off with the numerator, right? For the numerator, I have 1/1 plus 2/3y, right? So what's the LCD here? 3y, right? So I'm going to multiply this by 3y, but you got to be fair. What you do to the bottom, you got to do to the top, right? And then we're going to multiply the 3y by 1, and what we do to the bottom, we do to the top, right? So after that now, right, we have 1 times 3y plus 2 times 1, all divided by 3y. And then if we simplify this even further, I should have 3y plus 2/3y, right? So that's just the numerator. Now let me do the denominator. So on the denominator, I have 1/1 minus 5/xy, right? So what's my LCD there? XY, right? So I'm gonna multiply this by xy. But what I do to the bottom, I gotta do to the top, right? Multiply here by xy. Over here, I'm gonna multiply this by 1. But what I do to the bottom, I gotta do to the top. Oops, wrong one, sorry. So now, what do I have? I have 1 times xy minus 5 times 1 over xy, right? Simplify that further. I have xy minus 5 over xy. So now I have a fraction divided by a fraction, right? So what I want to do, keep, change, flip, right? So I'm going to keep the numerator. That. All right. So I'm going to keep the numerator, 3y plus 2 over 3y. I'm going to change the division now to multiplication. I'm going to use a dot multiplication of because we have x's in this question. And then I want to flip the denominator, right? So I'm going to have xy over xy minus 5, right? Now, all you have to do is you have to cross out the like terms, right? The only like term I have here is the y. So boom, boom, right? So what's my final answer? Huh? Just the y. Yeah, no, not the xy. Yeah, so because that addition sign is there, right? Like there's nothing else I could do with that. So my final answer is going to be x times 3y plus 2 divided by 3 times xy minus 5. And that'll be it. And then you could just type it in just like that. Remember the parentheses though, right? Like that's key. All right, go ahead. All right, x over
4x minus 12.
x over 4x minus 12 like this?
Yeah.
Okay.
Minus
Uh-huh.
x minus 4 up top.
Oh, 1 second. Okay, yeah. X minus 4 up top.
Yeah.
Okay.
Down the bottom. X
minus 3. Okay.
equals 180.
Equals 180.
No, 1.
1 over 8. All right, so all you got to do so all you have to do right here, right? First thing you want to do is factor, right? So let's factor this. So I'm gonna have x over, what's the factor of this? Tell me. Not 2.
3 and 1.
No.
Negative.
So I'm looking for the greatest common factor, the denominator. What is it? 4. And what's left over? Uh-huh. Very good. All right. Minus, we have the x minus 4 over here, over the x minus 3. And over here, I have what? I have like 4 times 2. All right. What's the LCD here? What's for the lowest common denominator for all 3? What is it?
What?
Not 12.
3.
No.
Plus
4 times 2. What else? Times what? X what? X minus 3, right? That's your LCD right there, right? Put that all together, what does that become? 8 times x minus 3. That's my LCD, right? So now I'm looking at the first term right here, right? The x over 4 times x minus 3. What can I multiply by that denominator to get 8 times x minus 3? So I'm looking at this denominator right here, right? I want to get that to look like this. 8 times x minus 3. What can I multiply by it to get it to 8 times x minus 3? By 2, right? So I'm going to multiply this by 2, but you know I got to be fair, right? What I do to the bottom, I do to the top, right? Over here, I have x minus 3. What can I multiply by that to get it to 8 times x minus 3? By 8, right? So I'm going to multiply this by 8. But what I do to the bottom, I got to do to the top. Okay, the last one, right? Let's say I have 8 right here. 4 times 2 is 8, right? What can I multiply by that to get it to x times, give me 8 times x minus 3? X minus 3, right? But what I do to the bottom, I got to do to the top. Now listen, because this is an equation, remember equations have equal signs, right? Because this is an equation, all I have to deal with now is just the numerator, nothing else, right? Just the numerator. So what do I have here? I have 2x minus 8 times x minus 4 equal to 1 times x minus 3. Did I lose anybody? Good? So this is just the numerator, the top portion of this question, right? Once I get all the denominators to look the same, because it's an equation, I can just work with the numerator now. Remember, equations have an equal sign, right? If this was an expression with no equal sign, I have to leave the denominator there in the answer, right? So, exactly, right? I'm going to distribute the negative 8. We're also going to distribute this 1 right here. Even though we know what that is, just for completion. That's why we're doing that. So we're going to have what now? 2x minus 8x. A negative times a negative is positive. 32, good. Is going to be equal to 1 times x is x, and 1 times negative 3 is negative 3. We good? All right, so now what I want to do, combine like terms, right? Combine like terms. So 2x minus 8x, what's that? Negative 6x, very good. Plus 32 is equal to x minus 3. So what do I want to do after that? I want to solve for x. So what should I do first? No wrong answers here. You want a minus 32 on both sides? Okay, let's do that. Minus 32, minus 32. So now I have negative 6x is equal to x minus, what's that, 35? Something like that. What do I do next after that? No. The other thing. Remember, I want all my x's on one side, all my numbers on the other. Move x to the other side, right? So I'm gonna subtract x from over here, but what I do to one side, what I do to the other, right? So negative 6x minus x is, nope, negative what? Negative 7x, which is equal to negative 35, right? And then now I want to solve for x. So I'm going to divide by negative 7. But what I do to one side, I got to do to the other, right? So now what do I have? X is equal to positive 5, right? And that's your answer. That's it.
But then what you put the square root.
No, the answer is 5. That's it.
What is that called?
This is solving rational equations. Yeah. That's it. Hold on one second. This thing is a pain. Go ahead. Oh, you want to make it smaller? I got you. This was that question. Did you get your question? You were able to see it? All right. All right. Sorry about that. All right, we good to go. So next question. What? So 15x cubed, okay? 25x squared. 60x like this? Okay. Just a factor? All right. So I'm looking at this and I want to know what's the greatest common factor here? 5x, right? So I'm going to factor out a 5x here. So what's left over? Good. 12, good. All right, that's not too bad. So now I want to factor this inside right here, right? So I have the 5x. Do you know how to do this, or do you want to do the AC method? All right. So then let's do the AC method, right? So A times C in this case is going to be 3 times negative 12, which is going to give me a negative 36. And then my B is equal to negative 5. So now I need two numbers that when I multiply them together will give me a negative 36. But when I add them together, will give me a negative 5. What are they? Yeah, negative 5. Yeah. Well, 6 times 6 is 36, but not 6 plus 6 is not 5. Yeah. Also, I know that one answer has to be, one of the numbers has to be negative and one has to be positive. The large, right? And you multiply, get negative 36, and when you add, you get negative 5. So, 4 and what? 9 and 4. All right, so let's see. Negative 9 times 4. Okay, that's negative 36, but negative 9 plus 4. Let's see, that's negative 5. All right, so we good to go, right? So now what do we do? You want to rewrite this. So I have 3x squared, but instead of the negative 5x, right, I want to do negative 9x plus 4x minus 12. Just like that, right? And then I want to group these. So I'm going to have a left-hand group and a right-hand group, right? So on my left-hand group, I have 3x squared minus 9x. What's the greatest common factor there? 3x, right? And then what's left over when I factor out 3x? X minus 3. Excellent, right? Now I have a positive 4x minus 12. What's the greatest common factor there? Right? Positive 4. And when I factor out a positive 4, what's left over? X what? Minus 3, right? So now greatest common factor one more time, right? I have, right, x minus 3 and 3x plus 4. That being said, come over here. X minus 3, 3x plus 4. This is your answer. And that's it. Yeah. Uh-huh. Got you. Yeah. And then just to continue the conversation, we won't do it, but let's just assume that it was equal 0. You would set each part equal to 0 and then get the 3 answers. Right, and the 5x equals 0. If there was an equal 0 here. Mhm. Yeah, it'd be like 5x equals 0 divided by 5 on both sides, x equals 0. Yeah, nothing crazy, just set equal to 0. All right, any more questions? Are we good? All right. Hold on, just zoom this in real quick. All right, go ahead. Okay.
One.
Mm-hmm.
One. X plus equals 5. Then the resolution for X1 equals and X to the wall. X one less than or greater than 90.
So
X two.
long story short, in this question, solve for x.
Yeah.
Right? Now, these are rational expressions. So if I'm gonna solve for x, that means I have to have the same denominator. Right? So that being said, what's the LCD here? Oh, it's bugging. So what is it? X plus 2. Say the other one? X minus 1. Okay. What else? Times 4, right? That whole thing is the LCD, right? So now I have x minus 1 here. What am I going to multiply this by? Remember, I wanted to look like this. So x plus 2, I heard that, and what else? And the 4, right? But we got to be fair. What we do to the bottom, we got to do to the top, right? It's 4 times x plus 2. Over here, I have x plus 2. What am I going to multiply this by?
X minus 1 and 4.
X minus 1 and 4. Good. Remember, we got to be fair. We do to the bottom, we got to do to the top, right? This is 4 times x minus 1. Yeah, it has to be. So now what am I going to multiply the 4 by?
X plus 2 and X.
Very good. X plus 2 and x minus 1. But you know, whatever I do to the bottom, I got to do to the top, right?
Yeah.
X plus 2. X minus 1, right? So now, because this is an equation, right? I'm going to just deal with the numerator. I don't have to deal with the denominator no more. So what do I have? I have 4 times x plus 2 plus 4 times x minus 1 is equal to 5 times x plus 2 times x minus 1. Right? Very simply, distribute, combine like terms, solve for x. That's the end of the question. Right? Okay, so 4x plus 8. Mm-hmm.
4 X
Uh-huh. Minus 4 equals what?
5.
Uh-huh.
5X.
Nope. What goes there? Distribute.
5.
Mhm. What is it?
X. Right here.
X squared, uh-huh.
Plus
Minus x, okay.
2X.
Plus 2x, okay.
Minus 2.
Minus 2, good. All right. Let's combine like terms now, all right? So what do I have here? I'm on the left-hand side now.
Right.
Yeah, so 8x, very good.
A minus 4.
Okay, what is that?
4.
So plus 4 is equal to 5 times what? Mm-hmm. No, what is that? Yeah, minus x plus 2x, what is that?
1X.
1x, right? So plus x, and then minus 2, right? Now, distribute the 5, right? So now what do I have? 8x plus 4 is equal to 5x squared plus 5x minus 10, right? Now remember, I want everything on one side equal to 0 because it's a quadratic, right? So I'm going to subtract 8x from over here. What I do to one side, I got to do to the other. I'm going to subtract 4 from over here. What I do to one side, I got to do to the other. All right? So what do I have? 0 is equal to 5x squared minus, what is that? 3x. Keep going.
6.
No. What is it?
14.
Negative what?
14.
Negative 14. Now we're talking. All right? So now factor that. All right? Can y'all tell me what it is, or do y'all need to go through the AC method? Okay, let's do it. So, oops. So A times C is equal to 5 times negative 14, which equals what? Negative negative 70. Excellent. And then I have a B term here, which is negative 3. Now I need two numbers, and when I multiply them, will give me a negative 70, but when I add them together, will give me a negative 3. What are they? 10 and 7. All right. So let's see. Negative 10 times 7. That's negative 70. Negative 10 plus 7 is negative 3. All right. Let's rewrite this. So I have 5x squared minus 10x plus 7x minus 14. Right? So what do I want to do? I want to group these, right? So I have a left-hand group and I have a right-hand group. On my left-hand group, right, that's the 5x squared minus 10x. What's the greatest common factor there? 5 what? 5x, right? And then what's left over? Nope. What's left over? Nope. Nope. What's left over? Nope. What's left over? Nope. What's left over? Nope. So whenever I factor out of 5x, remember, it's like I'm dividing by 5x. It's like I'm dividing by 5x. So x minus what? Nope, x minus what? X minus 2, very good. So it's all good. So now I'm looking at the right-hand group. So I have 7x minus 14, right? Right, plus 7, that's going to be my greatest common factor. And what's left over? X minus 2, right? And remember, it's like you're dividing by 7. It's like you're dividing by 7. That's how you get those numbers there, right? Greatest common factor one more time, x minus 2. And what's left over? 5x plus 7, right? After that, just kind of write that answer in over here, right? So we're going to have x minus 2, 5x plus 7, and that equals 0, right? So you already know what's going to happen. I'm going to set both of these equal to 0. So I have x minus 2 is equal to 0. I'm going to add 2 over here where I do the one side, do to the other. So I have x is equal to 2. That's one of my answers, right? Over here, I have 5x plus 7. I'm going to set that equal to 0, right? And then I want to solve for x. So I'm going to subtract 7 from over here. If I do the one side, do to the other. So now I have 5x is equal to negative 7. Then I'm going to divide by 5 to get x by itself. Or I do the one side, do to the other. So I have x is equal to negative 7 over 5. And that's my other answer. That's it. Now, remember what I was telling you before, right? When we're doing this section, we have to test our answers out, right? Right. Why is it incorrect? Tell me. No. Which answer is right and which answer is wrong? Is what? Is that right or wrong? It's wrong? Okay. Don't guess. To be lazy, you could just look at the LCD, right? Which answer would make the LCD 0? No, the negative 7 over 5 or the 2. Which one would make the LCD 0? These are two answers here. If none of them will make it 0, then they're all right answers. But if one of them will make it 0, then that's wrong. Mm-hmm. So would any one of those answers make the LCD 0? And like if you were to plug them in, would any one of those make it 0? Happy birthday! Oh. We finally 21. It's lit. So the short answer is no. None of those answers will make the LCD 0. So that means that both of these answers are correct.
That's one problem.
Yeah, that's one problem.
How do you-
Just plug it in. Like if you plug in like 2, for example, 2 plus 2 is 4, 2 minus 1 is 1. That's not 0. Yeah, just plug it
It
in.
says, okay, one, at least one, answer is not correct.
Why do you think it's wrong? They're right though, but why do you think it's wrong?
Oh, it's wrong?
Yeah.
I don't know.
What did it say in the instructions there?
It's real solution X one
Uh-huh,
and X two
uh-huh.
with one less than two.
Right, right. So the small one is x1 and the big one is x2. Right? So which answer is the small answer here?
X seven.
The -7/5, right? And then the big answer is a 2. Right? So you just have to put them in the right place. That's it.
System wrong?
Yeah. All right, let's jump into today's lesson. Oh, wait, somebody else had a question over here, right? You? Yeah, go ahead.
Square.
X minus 5. Oops, hold on. Negative x minus 5 or just x minus 5? Okay. So x minus 5 like this. X plus 6. Oh, 6x. Gotcha. Uh-huh. That's it? Okay. So this is already in a fraction divided by a fraction, right? So you can just go straight to keep, change, flip. So I'm going to keep the numerator, x minus 5 over 6x, and I'm going to flip the denominator, but change this to multiplication. I'm going to use dot multiplication because we have x's in this problem. I'm going to flip this, 3x over x minus 5. And then you just have to cross out the like terms, right? So x minus 5, x minus 5. On the bottom, okay. So x plus 5 like that. My fault. So keep the top, x plus 5, flip the bottom, same thing, right? So now they're different, so I can't cross them out. What I can do, I can cross out the x's, right? I can reduce the 3 and the 6, right? 3 goes into 3 once, 3 goes into 6 2 times. So what's my final answer? Final answer, x plus 5 over 2 times x minus 5. And that's it. Real quick one? All right, go ahead. Mm-hmm. Oh, like a big 10, like 5x over 2 like this?
5.
Uh-huh.
5 is 5.
Like that. All right. So when you have a whole number like that, right? Just put that over 1. And after that, just LCD, right? So what's the LCD here? Exactly, right? So all I'm going to do here is I'm going to multiply this by 5x minus 2. But what I do to the bottom, I got to do to the top. So that's 5x minus 2. So now what do I have? I have 10 times 5x minus 2 minus 5 all over 5x minus 2, right? After that, distribute, combine like terms, all that good stuff. So this is what? 50x minus 20 minus 5 all over 5x minus 2, right? Combine like terms, what do I have? 50x minus 25 all over 5x minus 2. And then now, greatest common factor in the numerator, what is it? 25, right? So I'm gonna factor out this 25, and that leaves me with what? 2x minus 1 over the 5x minus 2. This right here is your final answer. And yes, we do need to factor it out, right? Because we have to verify that nothing else in the numerator can cancel out with anything else in the denominator. Yeah. All right. Yeah. Let's see.
If I take out the 25 and just put 2x minus 1,
Mhm.
still central.
Let's see. Let's try the 50x minus 25 and see how that goes. Yeah, that works. It didn't want the multiplication in it. But just know though, like if it was a test, I'm expecting like this type of answer. Yeah, like factored out like that. Because we just want to verify that nothing else can cancel out in the denominator. All right, let's look at today's lesson. Real simple. All right. We'll probably be done with this in like a few minutes. Yeah. This is like a simple lesson. Yeah, I got you. I mean, you could watch the lesson for an hour and then take a nap after, I guess. Let's see. So what we're doing is we're going to be simplifying expressions with roots, right? But before I even get to that, right? Before I even get to that, let's have a little blast from the past real quick, just for fun. All right, help me out right here. So simplify, right? What's the answer for A? 81. Very good, right? Because you know that -9 squared is actually what? -9 times -9. That gives you the 81. How about B? -81. Very good. Because you know that -9 squared for this is actually -1 times 9 times 9. How about for C? Say it again. -243. Okay. That's good, right? Because that is what? -9 times -9 times -9. All right, remember this? Hmm? Like 3 -9s. What you got? Oh, 729? Awful. Yeah, I know I don't know my timetables. 729, yeah. Whatever 81 times 9 is. That's it. All right. But negative. All right. So that being said, oh, this is about to get real right here. Oh yeah, but the practice stuff is hard though. This one's about to be real right here. So I want you to round this number off. This is 3.846 to the nearest hundredth. What's the answer? Uh-huh. So what is it? 3 point what? Nope. 3.85. Now we're talking. Good. Right? Because I wanted to the nearest hundredth, right? So remember the hundredth place is the second place after the decimal, right? So I have to use the thousandth place, which was the 6, to round this one up. That's why. All right. Good stuff. Oh, here come the real blast from the past right now. All right, how about this? Simplify this for me. Oops. I want to cut it all off. What's the answer for A? X to the 6th power, right? And we know that that's good. That's because we're gonna have x to the 3 plus 3 power. That's how we multiply them. What about B? Y to the what? To the 6th power, right? Good. And then how about C? What's that? Good. Very good. We just add the powers together. Questions on that?
What was the number?
Like if it was like 3 to the third power,
Yeah.
yeah, you just give me a whole number answer for that. Yeah, I got you, I got you. So yeah, whenever we're multiplying exponents, we just add their powers and that's it. Just add. So 3 plus 3 plus 3 plus 3. Or 3 times 4, 12, whatever. Yeah. All right. So that being said, let's do a little terminology real quick before we get into like the real work. So here's what we're doing. So we're going to simplify expressions with roots, right? So we briefly looked at square roots. Remember that when a real number n is multiplied by itself, we write n to the second power or n squared, right? This number is called the square of n, and n is called the square root. For example, 13 squared is read 13 squared. 169 is called the square of 13, since 13 squared is equal to 169. 13 is the square root of 169. Right? So I'm kind of going in reverse here, right? We know that 13 squared is equal to 169. I'm going to give you the square root of 169, and I want you to give me back 13. What number multiplied by itself is going to give me 169 is 13, right? Because 13 times 13 is 169. All right? So those are roots. All right? Just, yeah, that's what this is. Mm-hmm. So just to kind of emphasize this just a little bit, just a smidget, all right? So square and square roots of a number, so square. If n squared is equal to m, then m is the square of n, right? For any number, right? Square root. If n squared is equal to m, then n is the square root of m, right? It's the same. I'm just trying to say that for any number, right? So if you plug in like, let's say 5 for n, m is 25, right? So 5, right, would be the square root of 25, and 25 is the square of 5. Yeah. But I say this just to generalize it. No? All right. Some more notes and important facts real quick before we get into this. So notice that negative 13 squared is equal to 169 also. So negative 13 is also the square root of 169. Therefore, both 13 and negative 13 are square roots of 169. So every positive number has two square roots, one positive and one negative. What if we only want the positive square root of a positive number? We use a radical sign and write the square root of m, for example, which denotes the positive square root of m. The positive square root is called the principal square root. This symbol, as well as other radicals to be introduced later, are grouping symbols. We also use the radical sign for the square root of 0. Because 0 squared is equal to 0, then the square root of 0 is equal to 0. Notice that 0 has only one square root, right? Reason for that, 0 is neither negative nor is it positive. It's its own thing. All right, so let's talk about square root notation. All right, you want to get that vocabulary down pat first, right? So square root notation. So the square root of m is read as the square root of m. If n squared is equal to m, then n is equal to the square root of m for n greater than or equal to 0. All right, so the square root, that's that check looking thing, that house thing, right? That's the radical sign. The radicand, right, is the number that's inside of it, right? So radical sign is outside, radicand, inside number. All right? Just trying to build the vocabulary a little bit before we jump into this, right? Just building the vocabulary a little bit. All right. So we know that every positive number has two square roots, and the radical sign indicates the positive one. We write the square root of 169 equal to 13. If we want to find the negative square root of a number, we place a negative in front of the radical sign. So for example, negative square root of 169 is equal to negative 13. That's simple. If there's a negative in front of the square root, answer is negative. Done. All right. Even though low-key we did a practice on this and already got the answer. Oh well. That being said, help me out. What's the answer here?
12.
12. Very good. Let me write that down real quick. So I have A. I heard the answer is 12. Very good. What about B? What's the answer? Negative 17. Very good. Well done. All right, so there's a negative on the outside. Square root of 289 is 17, and that's it. Square root of 144 is 12. That's the end of it. Just guess numbers.
Oh, you just guessed.
You guys try. You guys try. You're gonna need that on the fundamental engineering exam.
Doing engineering science.
Mhm.
My stuff with that, it's like he's doing analytical geometry and something.
It's light, it's mad easy.
I just seen like he showed me an iPad like the equation. He's like, I gotta find the tangent line, something, something. I was like,
I
yeah.
promise you, it's mad easy. You already know how to do it, matter of fact. Yeah.
But I don't know.
You remember when you had 2 points in high school, then they had that slope formula, y2 minus y1 over x2 minus x1? Literally the same thing, but a new vocabulary word. That's it.
I don't know, like mad work though. I seen like, yeah,
It's
math,
easy.
writing.
It's mad easy. Promise you. You don't even need a calculator for it. It's just like blah blah. -8, I heard that. Good. So I heard -8, and then I heard +15. Any questions on this? It's understandable? All right, cool. I guess y'all probably halfway done with the homework then, if y'all understand it, but okay. It's all good. Ooh, what happened? I don't like that sound. I don't like that sound. Let's try that again. Let's try it again. Oh, there we go. All right. So let's talk a little bit further, all right? So can we simplify the square root of -49? Is there a number whose square is -49, right? So I'm looking for something squared equal to -49. Any positive number squared is positive, right? Any negative number squared is positive. There is no real number equal to the square root of -49. The square root of a negative number is not a real number. All right. So just know that, right? If I ask you what is the square root of negative whatever, the answer is it's not a real number. Right? Just because the inside is negative, right? Because also think about it, right? How do I get a negative number? One number has to be positive, one number has to be negative. So there's no number that's positive and negative at the same time that can be multiplied together to give you this negative answer. So it's not real. Right? For you, it'll be real though, because you're doing electrical. When you hear them in class talking about J's and stuff, this is the J. What they're talking about. Oh, no. That's the current going through the circuits and all that. All right, so anyway, I have the square root, -196 and negative square root of 64. What's the answer for A? Not real, right? What about B? What's the answer? -8. Now we're talking, right? Questions on this?
Negative in the outside.
Right, it's the answer, but inside it's not real. Right? Yeah. So that's basically it. Right. It's imaginary. Oh no, this is the next test. I got you though.
No, you don't want this. It'll get way harder.
Nah, the next test is gonna be way easier. Like tomorrow's test, low key, is gonna be mad easy. Yeah. It's only 2 chapters. That's all it is. You got factoring and you got rational expressions. That's it. That's the whole test. All right. So A is not real, okay? B is -9. Very good. What happened? Oh yeah, that's coming. Yeah. That's actually the whole class. That's how we do it. We introduce something new and then we add, subtract, multiply, divide them. That's it. That's literally our whole week right there. You know? Both. Yeah. Yeah. So rational expressions, rational equations, factoring, right? So that's like when you have binomial, trinomial, four terms, right? That factoring, and then the equations for that. So like solving a quadratic equation, solving like the binomial and all that. Yeah, you do. You just set both answers equal to 0. It's nothing. All right. All right, let's build some vocabulary real quick. Yeah, this section is mostly vocabulary because we all know how to do these stuff already, right? All right, just keeping it simple real quick. So let's review some vocabulary first. We write n to the second power, right? We say n squared. If we write n to the third power, that's n cubed, right? N to the fourth power, n fourth power, n to the fifth power, n to the fifth power, right? So squared is just to the second power, cubed is to the third power. So the term squared and cubed comes from the formulas for area of a square and volume of a cube, right? So that's not for you. It's that calculus stuff. Yeah. But for you though, it's on the fundamental engineering exam. So learn that. It's all right. We just named them. Yeah. Yeah, that's in calculus. Yeah. We can look it up though. It's not so bad. All right. Yeah. All right, so let's look at this real quick, right? So let's say that I have n is equal to like 1, for example, right? 1 squared, which is 1 times 1, would be 1. 1 to the third power would be 1. 1 to the fourth power, 1. 1 to the fifth power, etc., right? Let's say that n was 2 now, right? Now we're going to get some differences here. N to the second power, which you know is 2 times 2, that's going to be 4, right? N to the third power, which we know is going to be 2 times 2 times 2, so 2 to the third is 8. N to the fourth, 16, and to the fifth, 32. So on and so forth, right? We could do it for 3, for 4, for 5. We could do it for any number going forward, right? That's that. What I want to take a look at though, right? Because we know how to do the positive numbers, right? Let's take a look at the negative numbers. It's real interesting now, right? Let's say that n is -1, right? So -1 squared It's positive one. That's like negative one times negative one. Negative one to the third power though, is negative one. Negative one to the fourth power, back is positive one. Negative one to the fifth power, is negative one. So you see that little flip-flop that's going on there, right? So when the power is odd, 1, 3, 5, 7, 17, right? The answer is a negative. But when the power is even, 2, 4, 6, 8, 10, whatever, right? The answers are positive, right? So notice that. So you notice how they just like flip back and forth, right? If it's negative 2 squared is positive 4, but negative 2 cubed is negative 8. Negative 2 to the fourth power is positive 16, but negative 2 to the fifth power is negative 32, right? So there's something to notice right there. Y'all really don't need to memorize that because y'all have calculators. But if you want to, go ahead. Me personally, like I still count my fingers and figure things out, so I'm with you if you haven't memorized it.
I was like, one over the factorization.
Yeah,
It's like, so 35 times one, whatever.
yeah.
Whatever, number or something like that. How do you do that?
I mean, he mad smart. I don't know nothing. Got to figure it all out.
So that's not in the timetable.
Some people memorize the timetable so they can play around like that. But like I said, when I was little, and then I was learning the timetables and I was starting to memorize them, they then asked me some multiplication question that wasn't even on the times table, like 13 times 2. And I'm like, yo, but how you do that? The timetable ended at 12, right? So then they showed me like how to do the long multiplication, 2 times 3, 2 times 1, 2 times 1 and all that, right? So after I saw that, I was like, bump this, I ain't memorizing this because I can always figure anything else out, So like there's only like a few timetables I know. Like I know my 1s, I know my 2s, I can figure out my 3s, I know my 5s, I know my 10s, my 11, 9 a little bit. I still got to figure it out. To be honest. But yeah, but from that, figure anything else out. All right, anyway. Notice the signs in the table. All powers of positive numbers, are positive, of course. But when we have a negative number, the even powers are positive and the odd powers are negative. So we'll copy the row with the powers of -2 to help you see this. So for example, if n was -2, -2 squared is +4, -2 to the third power is -8, -2 to the fourth power is 16, -2 to the fifth power, -32. So even power, positive result, odd power, negative result. All right? Observations right here. All right? Still building some vocabulary real quick before we get back to the math. All right? Want to be able to talk to y'all and use some big vocabulary words. So the nth root of a number, right? So if b to the n power is equal to a, then b is an nth root of a. The principal nth root of a is written as the nth root of a. N is called the index of the radical. All right? N is called the index of the radical. All right? So let's take a look at where I'm going with this. All right? I'll give you a real simple example just to explain this. Okay. So take a look. So just like we use the word cubed for b to the third power, we use the term cube root for the cube root of a, right? Or the third root of a, whatever, right? So we can refer to this figure to help with high roots. So for example, 4 to the third power is equal to 64, right? The cube root of 64 is equal to 4, right? Because 4 times 4 times 4, etc., right? 3 to the fourth power is equal to 81. The fourth root of 81 is equal to 3. Negative 2 to the fifth power is equal to negative 32. The fifth root of negative 32 is equal to negative 2. See that? All right, so odd roots, you could take a negative answer from that. But if it's an even root, you can't take a negative root of that. All right? Could we have an even root of a negative number? We know that the square root of a negative number is not a real number. The same is true for any even roots. Even roots of negative numbers are not real numbers. Odd roots of negative numbers are real numbers. All right? Keep that in mind right there. That's important right there. All right? Even roots of negative numbers are not real numbers. Odd roots of negative numbers are real numbers. All right?
But it's still not a real number though. It has the.
So if the root, right, is even root, so like let's say square root or fourth root, right? And the radicand, the number that's inside, is negative. That's not a real number, right?
But isn't it not a real number, it's negative in the first place?
No, because the root is even. Now, if it was reversed now, let's say that I had the root, the root was odd, right? Or like the index was odd of the root, right? And then now there was a negative number on the inside on the radicand. That is a real number. We can get an answer for that. So that's what that's saying. Just to generalize this just a little bit further, real quick. I just want to generalize this a little bit more. Show you some properties of this. So these are properties of the nth root of a. So when n, right, the index, right, is an even number and a, number on the radical, is greater than or equal to 0, meaning that it's positive, right? The nth root of a is a real number. When a is less than 0, meaning negative, then the nth root of a is not a real number. So when n is an odd number, right, the nth root of a is a real number for all values of a, right? So keep that in mind, keep that in mind, keep that in mind. Let's take a look at this. So, what is the cube root of 64? It's all good.
8.
8. I don't think so. What is it?
Oh, wait, I see, I didn't put the.
No, I want the cube root. So I want a number that multiplies by itself 3 times to give me 64. It's 4, right? So the cube root of 64 is equal to 4, right? Because 4 times 4, 16, 16 times 4, 32. I mean 64, what am I talking about? Sorry. B. What is the fourth root of 81? So I'm looking for a number that when it multiplies by itself 4 times will give me this. What is it? 3, right? Because 3 to the fourth power is 81. All right, how about C? Right? The fifth root of 32 is 2. Very good, right? 2 times 2 times 2 times 2, 32, right? All right, not bad, not bad. You guys try real quick.
It's kind of similar to scientific notation.
Kinda, sorta. Yeah. All right, try those out real quick. All right, we done? What's the answer for A? So I heard three. That's good. That's good. How about the answer for B? 4? Is it? I don't even know. 256. It is 4? All right. What about C? 3? All right, I agree with that. Questions on this? No questions? We all good? All right, bet.
How do we check it?
Let's raise it to the power. So like let's say for C, right? If I took 3 raised to the 5th power, just do the math on it. 3 times 3 times 3 times 3. And then see if you come out to 243, and that's it. All right. This kind of be like what? So that's like 9 times 9 times 3. So then that's like
Yeah.
81 times 3, and then boom. You know? That's how you do it. All right, kind of fun, right? Let's try another one, right? Just to make sure we got it down packed. Okay? And if you find this easy, by all means, jump to your homework, right? Because I'm just doing more of this. You know? So the cube root of negative 125, what do we think that is? What is it?
So,
How do I know
yeah,
that?
it's,
It's odd, right? So what's the answer? What is it? Close. Real close there. It's a part of the answer. What is it? No, no, it's a real number. What is it? Not three. -5. Now we're talking. Right? So when, remember now, you're doing the cube root, right? Of a negative number. So that's going to be a real answer, right? -5 to the third power. That's going to come out to -125, right? Let's take a look. -5 to the third, oops, is equal to what? -5 times -5 times -5. -5 and -5 is +25, but times -5, what does that become? -125. That's why it works, right? How about B? I'm gonna change the color because this is getting a little messy. What about B? No, B is a real number. -2. All right. So you do the fourth root of 16 and just add the negative on the outside to it. All right. No, if the negative's on the outside, it's real. If the negative is on the inside and it's an even root, then it's not real. Yeah. How about C? What we got for C? -3. Very good. Questions on this? Right? That's an odd root, right? 5, odd root. So then the fifth root of -243, -3, right? No questions on it? All right. You guys try. Yes. All right, we ready? All right, so how's A looking? -3, very good. How about B? Not real. All right, how about C? Very good. Questions on this? Because it's an even power, right? 4 is even. So that's why it's not real. If it was odd, be good to go. So we good?
Okay,
Yeah.
there was no odd number.
Then it's gonna have a real answer. Yeah. So we good? All right. So let's talk about something really interesting. At least I found this interesting. So we want to estimate and approximate roots. This is really, really cool. All right. So when we see a number with a radical sign, we often don't think about its numerical value. While we probably know that the square root of 4 is equal to 2, what is the value of the square root of 21? Or the cube root of 50, right? In some situations, a quick estimate is meaningful, and in others, it is convenient to have a decimal approximation, right? So to get a numerical estimate of a square root, we look for perfect square numbers closest to the radicand. To find an estimate of square root of 11, for example, we see that 11 is between perfect square numbers 9 and 16, right? So its square root then will be between 3 and 4, but closer to 3, of course, right? So for example, right, we know that 3 squared is 9, 4 squared is 16, and in between the 9 and the 16 is the 11. If I square root all three of them, right, I get the square root of 9 is 3, the square root of 16 is 4, and square root of 11 is in the middle. So I don't know exactly what square root of 11 is. You'd have to do that on the calculator. But I can tell you that square root of 11 is between the numbers 3 and 4. So it's 3 point something, right? That's what that means. Let's say I was talking about cube root, right? So if I wanted to find the cube root of 91, for example, right? I know that 91 is in between the cube root of 4, the cube of 4, which is 64, and the cube of 5, which is 125. So I know that 91 is between 4 and 5. I don't know exactly what it is, but I know it's going to be 4 point something, right? It's in between 4 and 5. All right, so similarly, we estimate the cube root of 91. We see that 91 is between perfect cube numbers 64 and 125. The cube root then will be between 4 and 5. All right. So let's have fun with this a little bit. All right. So we want to estimate each root between two consecutive whole numbers, right? So I want to know what is the square root of 105. By the way, this is A over here, right? I want to know what the square root of 105 is, right? Now, I know that 105, let me think, it's between 100, right? Which is like, if I say square root of 100, it's between the 100 and between, what's the next number after 100? 121, I think. Yeah. So the square root of 100 is 10. And then we're going to keep the square root of 105. I don't know what that is. And then that's in between. And square root of 121 is 11. So long story short, I don't know what the square root of 105 is, but I know that it's in between the numbers 10 and 11. So I know that on the calculator, it's going to give you 10 point something, right? That's what we're doing here. Let's look at B. So for B, I want to know what the cube root of 43 is, right? So let's go through our cubes real quick because I'm not even sure what that is, right? 2 cubed, I know is 8. 3 cubed, what's that? 27. Like we're getting closer, right? 4 cubed, what's that? 4 and 4 is 16, that's 64, right? Bam, so we found it. Yep, that's it. So we know that the cube root of 27 is going to be here, and the cube root of 64 will be here. So we know that 3 less than the cube root of 43, which is less than 4. So I don't know what the cube root of 43 is, but I know that it's going to be in between the numbers 3 and 4. Right? So the answer to it is 3 point something in the calculator. That's it. All right? Cool, right? No problem, no problem. I'm not going to ask you this in class, but I figured this might be something useful to you in the future. All right? Yeah. I mean, later on in life, all your classes are going to use calculators. I'm going to tell you the truth. So, yeah. I mean, come to the lab. Like I said, I don't have time to show you in here, but in the lab I do. All right. So kind of disappointing, I know, but that's the end of today's lesson.
Yay.
All right. So I told you it'd be mad quick.
A lot of stuff.
So if you guys want to do your homework now, cool, go ahead and catch up. I'm looking for everything from chapter 6 and chapter 7 to be done today, right? For our test for tomorrow. If you want to bounce, you could bounce. If you want to go over the review sheet, you could do that too. Whatever y'all want to do now, your time. This is being recorded as well, so I'm gonna post it later on tonight. Hopefully tonight, fingers crossed.
Trying to make sure all of it's done.
Awesome. So as long as this row right here says 100, we good.
So we'll go to this one.
Yeah. So, so you see like how that says 80 right there? So that's not done. And the 0 is not done.
This one right here.
Yeah.
I did 50, but every time I go to click on it to finish, it doesn't.
Oh, okay.
That's the only problem.
Which one is this? 3.5? Let me take a look at that. 3.5?
Yeah.
Really?
I completed everything. When I went to go finish the 3.5, certain questions that I got right. When I click more problem for 23, this is when
That's so weird. I've seen that problem like issues like that before.
try to log in, log out, go to another one and come back to see if it goes.
Yeah,
Every time I click on 23, that's
got you. Yeah, that's it. Yeah, yeah.
Will you stay here?
Yo, I catch you, man. That's, all right. Which number you said that was?
23.
Interesting. It's just that one that had that issue?
Yeah.
Okay. That is very interesting.
Said on the test it's gonna be everything from 6.1 to 7.4.
6.1 to 7.4, yeah. Yeah, the stuff for tonight's homework is not gonna be on it. All right, 1 second. All right, do me a favor, refresh and see if you still see it.
Now it says 100%.
Awesome. All right. You're welcome, no problem. Thank you for letting me know.
Yeah, probably have 2 problems.
All right,
Oh, you sure you know?
hold on. All right, go ahead.
2 over x minus 5
Mhm.
minus 2 equals 4 over x plus 5. It's a real solution are x1 and x2 with x1 less than equal to x2
So you want to make the whole number be over one,
over 1,
Right.
that part.
and then what's the
then
LCD?
that LCD would be, x minus
X minus 5.
x minus 2, x minus 5,
X minus 5 and what else?
x plus 5,
X plus 5, right?
and
And then now you got to get the LCD under everything, right? So we already have X minus 5 here. I'll multiply this by X plus 5. But what I do to the bottom, I gotta do to the top.
so what about the 2? Do you want to have by 2 as well or no?
Later on, I'm going to, right? This is a 1, so this is missing the X minus 5 and it's missing the X plus 5. So I'm gonna multiply that by the 1, but what I do to the
Gotcha.
bottom, I gotta do to the top. Right? Over here, I have X plus 5. I'm missing X minus 5, so I'm gonna multiply this by X minus 5. But what I do to the bottom, I gotta do to the top.
X minus 5.
Right? Now, because it's an equation with an equal sign, right? All I have to do here is just work with the numerator. So this is gonna be what? 2 times X plus 5 minus 2 times X minus 5, X plus 5 is equal to 4 times X minus 5. And all you gotta do is just distribute, combine like terms, solve for X, that's it, right? So
2 times x is 2x.
so I got
2 times 5 is 10.
plus 10.
2
All right.
times x is 2x.
Not quite. So what you want to do is -2 And then now distribute the fractions here, right? I mean, the factors here.
So negative two x.
No, x times x
X
is
times is x squared
x squared,
plus minus
so plus
five
five, what?
x,
5x. Okay, now what else?
five x,
So what's the next one?
five x.
Yeah, I have 5x. What's the next one after that? Let me see. I have, good
Oh,
night.
okay. It's
Happy
five.
birthday, by the way.
Yeah.
No, but what's this one?
What, that's not five x?
This is what?
Negative five.
Negative 5x, right? And then negative 5 times 5 is
Mhm.
negative 25, right? And then that equals, let's distribute this.
Four x
Uh-huh.
minus 20.
It's 20, right? So now combine like terms. What do I have? I have 2x plus 10 minus 2 times 5x, and negative 5x cancels out. This is x squared minus 25 equal to 4x minus 20, right? Distribute again, right? Now I'm distributing a negative 2.
So it's two x squared
So 2x plus 10.
minus two x squared
Uh-huh.
minus
Nope. Plus what?
25.
Nope. Plus what?
Two times 50.
50, right? Is equal to 4x minus 20, right? And then now, again, we want to combine like terms, right? So what do I have? I have negative 2x squared, right? Then I have a plus 2x plus what? Not 50. Plus what?
Plus 10.
10 and 50 as well.
10 times 60.
60, right? Is equal to 4x minus 20.
And you subtract 20 from 60.
Yeah, or not subtract, right?
All right,
I want to add 20 over here to get rid of it, but what I do to one side, I got to do to the other.
that's 80.
And then I also want to subtract 4x over here. And what I do to one side, I got to do to the other, subtract 4x from over here. So now what do I have, right? I have negative 2x squared minus 2x plus 80 is equal to 0, right? Greatest
So this
common
is the
factor?
80. We do this method.
We could, right? But first we should do the greatest common factor. So what do they have in common?
4
Nope. What do they have in common?
negative
Negative what?
2
Negative 2, right? So I'm gonna factor out a negative 2. So when I factor out negative 2, what's left over? X squared.
yeah,
What else?
minus
Not minus,
plus
plus
x.
x. Very good.
Close parentheses.
Oh,
Oh,
last number. What is that?
40,
Close.
20
Mhm.
times 2.
Remember when you factor out a negative 2, it's like you're divided by negative 2. You're divided by negative 2, like you're divided by negative 2.
Negative 40.
Negative 40, very good. And then that is equal to 0, right? And then now, two numbers that multiply to give you 40, and when you add them together, will give you a positive 1. What are they?
40 times 1.
You said 40 times 1?
Yeah.
So 40 times 1 is, well, actually, this is negative 40, right? So one got to be positive, one got to be negative, right?
So negative 20.
So it's x and x. Negative 20 times what?
Negative 20. 2.
Well, okay, so 20 times 2, that would be 40, but does
Yeah,
that add up to a 1?
Uh,
So let's try something else.
20.
20 times 4 is 80, though. That won't work. I want two numbers that multiply to 40.
20 and 20.
Well, 20 and 20 is what, 400? 40, yeah.
4 times. What? 10 times 4?
10 times 4, okay. So the, what you call it? The larger number has to be positive and the smaller number is negative. So
10.
let's see, 10 times negative 4 is negative 40, but 10 plus negative 4 is positive 6, not 1.
Oh, this is something.
So let's see. We use the tree,
20,
right?
20,
Oh, look, we're gonna use a tree. 10 times 4. And what is this? 2 times 5. 2 times 2. So I'm looking for some combination of the numbers here, right? How about doesn't quite look like it's gonna work. You see a question?
so, put this down.
I just want to make sure that we did it right from the beginning.
I just have.
Minus 2. Plus 5. Let me check.
Okay, you know, the problem, you made the problem. I else much else.
It's not that I can't answer it. It's just that there's a technique to answer this that I haven't taught y'all yet.
Okay.
So I want to see if there's another way to do it. This is not such a great question. Which question was that?
7.4, sub-rational equation,
And what number?
problem 5.
Okay. Give me 1 second.
It's a this whole question.
All right, just bear with me 1 second. 2x plus 2. Plus. Squared minus. Hey, don't mind me for a second. I'm just running through this quick problem. real quick. Mm-hmm. Get to the bottom, you get to the top. So this one will be 2x times x minus 6 plus x minus 2 4
Yeah, 11, so.
Negative 12 plus 1, negative 11. Negative 12 plus 1. Okay, so we're good to go. All right, refresh your page for me. Mhm.
After 7.
Yeah, no problem. Take your time. All right.
Right.
So you got 2x over x minus 2 plus 1 over x minus 7 equals 5 over x squared minus 9x plus 14. Huh? Yeah. So help me out real quick. How do I do this?
Wait, that's the, oh, yeah. So, wait, I only have one more topic.
How do I do this?
You have, what you do to the bottom of the top, x plus 7,
Mm-hmm.
and x plus 7 on the top. X
So,
minus 7, sorry.
so I'm gonna factor the other side, right?
Yeah.
So I have 2x over x minus 2 plus 1 over x minus 7. And then that's equal to 5 over what?
Plus 2, 1, 3.
That's a square, I think.
Huh?
Yeah.
Yeah, minus 9x,
So what is it?
x squared.
No, no, I want the factor of it.
Oh,
What is it? You can look on the board if you want. You don't have to squint.
okay.
What is
So
it?
the x, the x,
3x? What's the factor of that?
x,
Uh-huh.
and x again.
Uh-huh. So two numbers that multiply to 14 and add up to negative 9.
7 and 2,
7 and 2. All right. What's the signs?
plus 7,
Plus 7 minus 2? No.
minus 7,
No.
plus 7. They're both negative?
No. So negative 7 times negative 2 is positive 14. Negative 7 plus negative 2 is negative 9.
Mhm.
So they're both negative, right? So what's the LCD? What is that?
7,
Mhm.
14,
14, no. Just write it up here. LCD. What is it?
plus 7,
Mhm.
plus 2,
No.
so 2 plus 2 times 14.
So I'm looking at the denominators here, right? Right? What is the LCD for all three of those?
14.
No. It's two things multiplied to each other. What are they?
Yeah. So,
Not 10.
two numbers multiplied would be 7 and 21.
Not 21.
And it's not 14.
Not 14.
So that's
It's one of the denominators there.
7,
What's the denominator?
the bottom number,
Yeah, so what is it?
x minus 7,
X minus 7, and what else?
x minus 2.
And x minus 2. All right, so that's the LCD. Right, so now I have x minus 2 right here. I want to get that to look like the LCD, so what do I have to multiply this by?
Bottom, x
Yeah.
minus 7.
X minus 7, but what I do to the bottom, I gotta do to the top.
7.
Over here, I have x minus 7, I need it to look
Then you
like
got x minus 2,
x minus
x
2,
minus,
exactly, whether it's the bottom to the top. And over here is already there, so this is just like multiplying by 1, right? So what do I have now, right? I have 2x times x minus 7 plus 1 times x minus 2 is equal to 5 times 1, right? And what do I do now,
distribute 2x,
right? I'm gonna distribute this onto both terms, bam, bam,
that's 2x,
right? So I have 2x squared
minus 14,
minus 14 what? Uh-huh,
plus
plus
1x,
1x,
net minus 2,
minus 2
equals 5.
equals 5. Very good, right? Combine like terms now, right? So I have 2x squared minus what?
14,
Nope. 14, negative 14x plus x is what?
13,
Right? Negative 13x minus 2 equals 5. And what do I do after that?
subtract
Subtract what?
5,
Mm-hmm. Good.
2,
So now what do I have? I have 2x squared minus 13x. What's negative 2 minus 5? Minus 7 is equal to 0, right? So now I need two numbers. Let's see if we can factor this, right? I know that this is going to be what? 2x here and x. Two numbers that multiply to give me 7. What are they?
7 and 1,
7 and 1, right? I have a negative 13, so this should be negative 7 here, positive 1. If you have trouble with that, AC method. It'll go through with that, right? Final step, you just got to solve for x, right? So you have 2x plus 1 is equal to 0, right? I'm going to solve for x, so subtract 1. So I have 2x is equal to negative 1, divide by 2.
so that's negative 1 over 2.
So x is equal to negative 1 over 2. And then I have x minus 7 is equal to 0. I'm going to add 7 over here. I do the one side, do to the other. So I have x is equal to 7. So these are my answers here. All right.
That's correct.
Yeah.
I got all my homework done.
All right. Awesome. You're welcome. So anybody else, any questions? CPH room 303.
What day?
So Monday through Saturday, there's tutoring, right?
Oh, yeah.
Online is 12 to 6, Monday through Saturday. In person is Monday through Thursday, 12 to 6. Yeah. You're welcome anytime. Anytime you want to, you could just walk in if you're going in person. Prefer if you can make an appointment. All right, cool. Yeah, online is cool. All right. See. Remember though, you have to make the appointment online so that they can email you the link.
Oh,
Yeah. What about y'all? Y'all want to go? Okay. All right. So is there any questions on the review that looks crazy? You don't understand? No. Yeah. Gotcha. All right. Yeah.
I focus.
Yeah. Yeah. Let's back one. All right. So I have 9x squared. Y cubed. Oh, like this? Okay. Yeah, that one. Mhm. Yeah. And then y to the 5th power, right? So, mhm. Very good. 3. Okay, minus y squared. Yeah. Hmm. That's good. 3 is not a perfect square, so I can't break that any further. So that's it. Yep, that's the review. Yeah. So that's what the exam is gonna be like. Not that many questions, but it's gonna be basically that. Yeah. I mean, if you want, you could skim it right now if there's anything you want to go over. Yeah. There's one question on there. Let me see on the review. Let me just open it up on mine. So I'm gonna give you an example of something. Bear with me. All right, if you look at question number 4, letter B, right? Yeah, letter B. I'm not asking you that. Let me just tell you straight up. Yeah. I'm not asking you that. I'm gonna just tell you, be honest with you on that. All right. We didn't go over 3 terms being multiplied and divided and all that. If y'all want to know how to do it, come to tutoring. Happy to show you, but not asking you that. Also, you see something like G. I'm not asking you G either. Right? This is question 4. Yeah, like G, I'm not gonna ask you G either. Not that you can't do it, it's just that we never went over 3 terms being added, multiplied, and divided. We can figure it out, but I'm not gonna ask you that on the test. Or in G, yeah. But everything else looks like it'll be fair game. These topics? Okay, so the whole top is factoring, right? And then you have the solving the quadratic equations, right? That's the second topic, right? The third topic is simplifying rational expressions, right? And that could be adding, subtracting, multiplying, dividing, etc. The last topic on there is solving rational equations. Right. And then simplify rational expressions. Yeah. Basically, it's the fractions that don't have an equal sign. Right? Just simplifying them. So you factor them, you cross out the like terms, that's the end of it. Right? Expressions. And then the last one is solving rational equations. Rational equations. So whenever I say solve for something, I'm looking for you to just give me an answer like x equals this, x equals that, right? But if it's an expression, I'm just looking for you to simplify it. You know?
They usually say expression to equal sign
Right,
equation.
right. Also, my
expression you only say you would
Mhm. Simplify it.
to simplify.
Yeah. Cross out any like terms, and then that's your answer, right? But equations, I need an answer. It's not bad though. If you look at the homework, it's everything from the homework. The homework is just more examples of what the review is. No, it sounds like a lot, but I promise you it's not.
Yeah.
4 topics, real simple.
No, I get what you're saying with this.
Yeah. The first test had way more topics on it than this.
Yeah.
Yeah, this is just 2. Sorry, tomorrow's another day.
Yeah, you know, we have some.
Yeah.
But maybe partner will go money go up.
Yeah. Got you. Got you. Well, you know what? Like, I'm still recording this. Real quick. So, just I want people in the recording to know this. So, I got put on the schedule for tutoring on Tuesday, so I'll be there tomorrow.
Yeah, that's tomorrow.
Yeah. So 1 to 5. Yeah. So like going forward for like the rest of the class, I'll be in tutoring on Tuesdays as well. So Monday, Tuesday, Wednesday, I'm there, and then Saturday I'm there online, right? It's nothing I was gonna tell you. This Wednesday, right? Yeah, this Wednesday now, pantry, right? So
You didn't mention that.
Yeah. I wish I said it earlier in class, but if anybody's watching online, this Wednesday is pantry, so come get your groceries, you know? If you have to sign up with the website, sign up, you know, and then come through. You know? I just wanted to get that on the recording, that's all.
Yeah, no,
Yeah.
realize.
Yeah.
Stop there.
But I mean, if you guys have no more questions, I'll stop the recording and then. Everything. All right. All right, no problem, no problem. Alright. So yeah, for homework tonight, just focus on getting all of chapter 6 and chapter 7 done. If you finish all of chapter 6 and chapter 7, then you could go on and do the 8.1, which was today's lesson. And if you're missing anything from the previous homework, you can do those as well. All right, let me stop the recording then. Real quick. You good, you good. Everyone have a good night. All right. See you guys in class tomorrow.